My name is Amy Maddox, and this is my MSDS 692 practicum submission, Creating Cloud Environments with Apache CloudStack. For my practicum project, I opted to participate in the data engineering project that was offered this term. I'll begin by outlining the general problem to create a data science student cloud. Students enrolled in data science or data engineering programs at Regis need access to reliable machines where they will have access to the required programs needed to complete assignments. The concept for the data engineering practicum project is to create a cloud environment for data science and data engineering students, similar to a cloud service provider such as Google Cloud Products or Amazon Web Services. A university-based cloud provides students with an option that is built and maintained by professors, university IT staff, and even data science and data engineering students. This is important because the individuals working on the platform will have a deep understanding of how the students will be using the platform. Additionally, unlike other cloud service providers like AWS, GCP, or Azure, this service would be no cost or low cost to students, likely covered by tuition or the university technology fee. A university-based cloud would be customized to the student population and university staff by professors in the data engineering and data science departments. Students will have access to quick and helpful technical support, perhaps even provided by current or former students that will be working on the cloud service. This will ensure that student issues are resolved quickly and efficiently and allow students to get back to their work faster. The application used for this project is called Apache CloudStack. CloudStack is an open source foundation for developing cloud computing projects. It's written in Java and can be used to deploy public, private, or hybrid infrastructure as a service clouds. The first step in the project was to install CloudStack on the server. The team was divided into 3 groups, and each group was assigned to one of the 3 servers available for the project. The server that I was assigned to has a previous version of CloudStack installed on it, and because I'm installing a newer version, I want to first completely remove the current version. Because this is not actively being used by anyone, there is not really any downside to completing the process this way, and it's the best way to learn the process to install a CloudStack manager and hypervisor. I do run into a few issues through the process, as I will discuss in the following slides. Challenge number 1, removing the previous version of CloudStack. As mentioned previously, the CloudStack application had to be removed from the server. This includes the CloudStack manager, CloudStack agent, utilities, and relevant directories. If done incorrectly, there will be issues with the new install. Unfortunately, there isn't a tutorial or reinstallation or removal guide that kind of guides you on how to remove a version of CloudStack. This isn't necessarily an issue, but it was a hurdle to overcome before the installation could be completed. The resolution to this issue was to remove the appropriate components using Linux commands in the server terminal. Once completed, I can install the most current version of CloudStack using the quick installation guide on the CloudStack website. Challenge number 2, unable to add the host in the CloudStack setup. After completing the CloudStack install, I move on to the web interface. During this process, I can set up various aspects of the cloud, including zones, pods, clusters, storage, and the host. During the setup, I received an error while attempting to add the host. It was determined that this was related to security keys, which were not removed when the previous version of CloudStack was removed. This prevented new security keys from being issued and prevented the host from being added. To resolve the issue, I need to remove the directory that contains the security keys, remove the CloudStack agent, and then reinstall the CloudStack agent. Once that is complete, I restart the CloudStack manager and the CloudStack agent, and then I can add the host. Challenge number 3, unable to add the secondary storage in the CloudStack setup. The host is successfully installed and I am able to proceed to the next step of the CloudStack setup. The setup stalls when adding the secondary storage. The secondary network file system mount is not recognized by CloudStack. This prevents the server from recognizing the NFS mount, which prevents the secondary storage from adding. Without the NFS working properly, the VM template is not found, which will not allow the VMs or the virtual machines to start properly. The resolution for this issue is very simple. It was just a small misstep within the quick installation guide where the domain name needs to be added to one of the configuration files. However, through the process of identifying the issue, it was suspected that other files were actually responsible for the issue, and those files and directories were removed. This complicated the process quite a bit, but once the root cause was identified, we were able to install the CloudStack agent and manager and restart them. And then once that was complete, the secondary storage is added successfully. The CloudStack setup is completed and the student cloud is ready to be designed for student use. My CloudStack design process included 4 separate steps. Step 1, create templates within CloudStack. This is done easily by uploading a template or ISO of a specific operating system. Step 2, create virtual machines from the template or ISO created in step 1. For this specific project, I'll be referring to an Ubuntu ISO. Step 3, load applications to the virtual machine. And step 4, use the completed virtual machine with the applications to create a new template. Creating templates and ISOs. The first step in the CloudStack design process is to add templates and ISOs to CloudStack. This is important because the templates and ISOs provide the users the templates to launch their virtual machines. However, CloudStack is built with a default virtual machine template for this exact purpose. I download the 18.04 version of Ubuntu through the wget function in the server's terminal and then transfer the file to CloudStack to register it as an ISO. While 18.04 is not the newest version of Ubuntu, it is the newest version that CloudStack will accept. Creating a virtual machine. The next step of this process involves creating a virtual machine out of the newer template or ISO. Ubuntu is a large operating system and will not install properly on the compute offerings that come default with CloudStack, which are small and medium. Before creating the new virtual machine, I need to first create a large compute offering, which is a quick and simple process so that I can install Ubuntu on the virtual machine. Adding applications to the virtual machine. This step of the process is vital to the project. A good amount of time was spent during the installation phase and learning the fundamentals of CloudStack, so due to time limitations, I needed to determine a few foundational applications that need to be included in a virtual machine template for data science and data engineering students. Based on my personal experience as a data science student, I chose R and RStudio, Python, and Anaconda, which includes Jupyter Notebook. Creating a virtual machine, a template out of the virtual machine. The final step of the process is to take the completed virtual machine with the new applications and create a template. This template will be available as a virtual machine template to users that can access the applications, add new applications, update the applications, and so on. Now let's take a quick look at the live environment. This is the live environment of CloudStack once you're logged in. And if we go into the instances section, you can see that we have 2 virtual machines running. The first Ubuntu is the initial one where the applications were initially installed. Under templates, there are several templates that are installed. And the one that says data science is the one where the applications were installed and then the template was created with those applications. And that's the one, we go back to instances, where Ubuntu 2 was created from that. And that's our most recent one. So if we go here and look at the console, it shows us that we have Python 3.8.3 installed. And if we type the code, the command for R, it will pull up R so we can run R commands. Oops. And that will pull up Jupyter Notebook. And our studio server is a little bit different. You would actually have to type in the IP address of the server or the IP address of the virtual machine :8787, which is the port that it's installed on. And then that would bring up the version of our studio. Which those are the applications that are currently running on this particular template. So for recommendations for future development, there are just a couple of recommendations that I would have given just my brief experience with CloudStack. I would recommend to first experiment with more templates and ISOs. We're just kind of tapping the surface with what's available. There could be experimentation with Windows templates, Mac templates. There's more CentOS and Ubuntu templates. The sky's kind of the limit where that goes. Add more applications for data science and data engineering, and more. There's a lot out there that could be installed on these machines. Add additional compute offerings as needed and as required. You could add additional disk offerings. There's a lot that could be done there as well. And then customize the user interface for student use. I know there is a newer user interface that's coming out. I don't know what that's going to look like as far as on the student side, but I think that is something to look into as well. Thank you so much for watching, and let me know if you have any questions that you might have.